Hello guys, my name is Akash Khowaja. I'm doing my computer system networking. I'm already in my final year. Here I'm present with my video 2 final year project 2. So my project is about human gait. I have to make a device distance which will measure the accurate distance of the human walk. The objective of this project is to build a system that allow the analysis and collection of data during human gait as one of the most automatic and physical activities that majority of human beings practice on their everyday life. I in my past work I did my code for IMU. I already showed in my past video outcome of the force sensor that all the three force sensors are working properly and prototype progress. My prototype is already built up. Only the last I have to just redo build again. So here we can see that maximize gait that uh, here is a patient with a weak heel strike on weak side. So if we can use the device into both leg, then we can know that the patient have some problem with any other leg. But here we are using only one. Here you can see that the interleg spring and thing in leg, knee angle and shin angle. So actually we want to know knee angle and shin angle, but that's not possible because for that we need to calculate the thing angle and interleg angle because at the top there is a point. Changing angle percentage time, it will give an angle of velocity from vertical. Here you can see we want to know this knee angle, but we can't measure time all the way back and forward with angle of velocity. So here we can measure the time in the top. It will give you how many degree you move, and we'll double check both angle side. When we get one side angle, we get another angle, so we can calculate from one angle. We can just calculate for the same for another angle, but there is an error in small error when we walk back step. When you step off, there is very small space off, so this error we have to calculate about this error as well. Phases of the normal gait cycle. The gait cycle is divided into stance phases and swing phases. The stance phases, which is defined as the heel to toe contact of the foot, accounts of around 60% of the gait cycle. The swing phases accounts of the remaining 40%. The stance phases can be divided into heel strike. The first feet, you can see that contact of the heel with the floor, foot flat phase, the period during which the complete foot is in the contact with the ground, and the proposal phases, the termination of stance phases, which start when the heel levels the ground and end with complete step of the tip of the foot. So here you can see I present with the graph. This is the outcome of the all the four senses. So here we can see that the ankle joint angle, exclusion, torque and exclusion, power, population average, normalized from heel contact to heel contact for ankle joint angle, acceleration torque and acceleration angle, joint mechanical power of the 10 power conditions. Here you can see in this picture that the angle of the people phases of human locomotion and related biomechanical event according to the proportional contact of one leg and the ground. A gait cycle is composed by a stance where the foot is on the ground and swing stance can be subdivided into four phases. Here we can see loading response in which both limbs are in contact with ground. Mid stance starting at contractile toe off, terminal stance starting at heel rise and pre-swing in which gain both limbs are in contact with the ground. With respect to the timing, the gross normal Distribution of the floor content periods is 60% for stance or 40% of swing. Timing of the phase of stance is 100% for each double stance, interval loading response and pre-swing, and 40% of single leg support. So this is the overall percentage of the human walking. Thank you very much for listening me carefully. I will see you guys in my video 3. Thank you very much.